One thing about math that not all kids understand is that we can represent it in a litany of ways, right? This right now is just a relationship represented as a list of ordered pairs, X and Y values, okay? I can represent the same exact relation as an X and a Y table. And the reason I want to talk about that is because it's a lot easier to answer this specific question when it's written out like this than when it's written out as a list of ordered pairs. For example, -6 is going to produce a 9. -3 is going to produce a 6. 0 produces a 3. And 4 produces a 0. So this table right here is now a lot easier for me to determine if it's linear or not. Sometimes when we have a list like this, just because it's horizontal, there's a lot of numbers and they're organized a certain way, it's not as easy to see if there's a consistent pattern throughout. When we have a table of values, we can just do our change lines off to the side here. So what is it that we're specifically looking for to determine if something's linear? We have to have a constant rate of change between our change in Y over our change in X. So as you see here, 9 goes to 6, that's -3. 6 goes to 3, that's -3. 3 goes to 0, that's -3. We're consistent over here, but from -6 to -3, we're going up 3, then we're going up 3 more, and then from 0 to 4, we're going up 4. So if you notice, we had a slope of -3 over 3, which equals -1. But then when I go down here to this change between points, we have a slope of -3 over 4, which is not equivalent to -1. So A is not consistent. We've now determined that A is not linear. So maybe I'll put an NL just to keep things organized over here. And we got to check each and every one of these. So could you plot this point, plot this point, plot this point, plot this point on a graph and see if it's a line? Yes, because linear means it has a constant rate of change, which means that when graphed, it's coming out as a line. I like to just stick with 1, 1, draw my X and my Y columns, 2, 3, 4, 5. So what I really want you to understand from this video is that just because math was given to you as a list of ordered pairs, nothing is holding you back from writing it in a different representation that makes more sense or is easier to work out of if that's what you want to do. So 1 to 3 plus 2, 2 to 5 plus 2, 5 to 7 plus 2. We're consistent on the Y's. But then we go 1 to 2, 2 to 4, 4 to 5. That's up 1, then we go up 2, then we go up 1 again. There's not consistency here. So this one would not be linear. Okay? So we're going to say non-linear here. Now, some of you have strong enough number sense to just look at these. You don't necessarily have to write the table out, draw your change lines. That takes time, and we don't always want to use all the time in the world. We could say -4 to -2. Most of us can do some mental math and just say that would be up 2, and then all of a sudden I'm going up 3. -4 to -2, up 2. -2 to 1 would be up 3. So if I'm going up 2, then up 3, we got to see if things stay consistent with the Y's. -4 to -2, that's up 2, which means my next one better be up 3. -2 to 0, not up 3. But notice that everything's kind of drawn on top of each other. It's a lot more difficult to keep things organized when it's written out as a list of ordered pairs like this. So this one would also not be linear. Now our assumption would be one of them's got to be linear. Don't just be so quick to judge. Make sure you check it. So let's go and we'll do the table with this last one. So I'm going to make an X and a Y column. 3, 7, 3, 7, 5, 1, 5, 1, 6, -2, and 7, -5. Now when we do our change lines here, 7 to 1, I'm going down 6. 3 to 5, I'm going up 2. So I'm going to take change in Y, put it over change in X. That is a -6 over a 2, which is equivalent to -3. -6 divided by 2 makes -3. The reason I'm doing this is because what you're going to notice here, 1 to -2, I'm not going down 6, I'm going down 3. But over here, I'm not going up 2. So things changed here. That doesn't mean this isn't a linear function. Doesn't mean there's not a constant rate of change just because the Y is not consistent. If the X is also not consistent, plus 1, we need to take the change in Y, put it over the change in X. That's a -3 over a 1. Well, look what happens when we put -3 over 1. We get -3 again. Those match up. This is simplified, this is not simplified, that's all that's saying. And then 2 to -5, again, we're going down 3, and I gotta hope that over here is +1, because down 3 plus 1 needs to be down 3 plus 1. It is, therefore, this is going to be our linear function out of the 4 represented. So big takeaway, just because they give it to you as a list of ordered pairs doesn't mean you can't change it and represent it some other way that makes more sense to you. Maybe you like working out of ordered pairs. Great, I don't, okay? I'd much rather work with a table of values. In my opinion, that's an easier way to go about the problem, okay? Again, you can put it into a graph. You can plot the points out and see if it comes out as a line. You can make a table of values. There's a lot of different things you can do with this to determine if you're dealing with something that has a linear, which means constant rate of change. Hopefully this makes sense. Study hard and good luck on your upcoming test.